So we should start the session. Assalamualaikum warahmatullahi. Your micro-credential is what the permission control. Micro-credential is different thing. What the permission control is a different thing. I will explain. I am Carol Anya from the Department of Chemical Engineering and Energy Sustainability, Faculty of Engineering, University of Sarawak, Sarawak. So this is the contact number, email, phone, and office number. So before we start, NTW or National Training Week 2025 is supporting all 17 SDG goals. However, for this seminar, it will be related to SDG number 6, clean water and sanitation. So SDG 6 focusing on ensuring the clean water and sanitation for all. So how does wastewater pollution control relate to SDG 6? So the proper treatment of domestic industrial wastewater ensures safe water reuse, prevent contamination of natural water sources, improving the water quality and the health and environmental benefit by reducing or lowering the risk of waterborne disease and protect the aquatic life. This is how water pollution control relate to SDG number 6. So micro-credential, I think some of you might heard about the term, though doesn't necessarily understand what is micro-credential. So micro-credential, this is the definition. It's a short competency-based recognition that demonstrates proficiency in a specific skill or subject area. This definition is from Times Magazine. They often earn through a series of courses and culminate in a digital page from accredited institutions such as UNIMAS, similarly to players that you possess the focus knowledge. Another thing is for by doing micro credential, there are possibility because we have April M now. We have April A, April C. So what is April APEL? For example, April A is using experience in order to enter the higher degree. April C is for the credit transfer based on experience, and another one is April M. And this one is the micro credential, meaning if you process the digital badge from accredited institution, you can apply for credit transfer or exemption when you enroll in a higher degree. For UNIMAS, this is how the badge look like. Learner who successfully complete the micro-credential courses receive digital badges from UNIMAS. These badges can be shared on professional platforms such as LinkedIn, Resume, and Portfolio to highlight your skill. So municipal wastewater treatment system, the degrees of treatment. The alternative for municipal wastewater treatment system fall into three major categories. Primary, secondary, tertiary. This is urgent knowledge. The major goal of primary treatment is to remove from wastewater those pollutants that will either settle or float. The major goal of secondary treatment is to remove the soluble BOD5 and skip the primary process. Tertiary treatment is to process more. The process may involve the chemical treatment and filtration of the wastewater. So the higher the treatment, tertiary treatment, the more expensive, but the cleaner the water. This is the degree of treatment. Direct chamber equalization, basic this is the pre-treatment, then go for primary settling, start the primary treatment, secondary treatment, and tertiary treatment. Okay. Barek, I will not go in detail like what is each of the treatment because so many. Even the pre-treatment have at least three Barek chamber and equalization basin before the primary treatment start. Now, in this short period, I just show you how the Barek design is using a solver program in Excel. What is bar rack? So the bar rack is look like this. It's a screen. So the first device encountered by the primary by the wastewater treatment the plant is a bar rack. Yeah, any treatment, even the not necessarily wastewater, even the water treatment, they have a bar rack to remove the large object. It would damage the palm, the valve after that pump and valve normally in when it started the primary treatment. The trash bag have large opening, 40 to 150 millimeter, designed to prevent large objects such as log from entering the plant. We can say this is a physical separation, sorry, mechanical separation. The nomenclature of rack and screen. So we have a trash rack, bar rack, of course, screen, fine screen, refine screen, micro screen. Does so each of these type have different opening. The smaller it is, the better it can separate, but uh, it will get say, damaged or clogged if suddenly you choose to use micro screen at the first uh, treatment. It depend on the raw material, oh, sorry, the raw water that enter the treatment system. So for trash rack, for example, opening is 50 to 40 to 150 mm. So the typical use is to prevent lock stump heavy debris. So for bar rack, only 6 to 75 millimeter. This is to remove rack debris, large solid, which normally used in wastewater treatment plant. Okay. So this is based on Metcalf and AD. So anyone who do design, this book is, I would say, well referred book. Metcalf and AD is very, say, detail, although it's already years already published. Still, we refer to this book just to get the idea how to do the design. This fall into four categories: chain-driven, supporting trade, catenary, and continuous belt design. Cleaning mechanism for the bar rack. This is bar rack design. For example, A here is a front clean, front return chain driven. So the chain will enter here and pick up the debris here. And then it will bring the debris into the screening through. It said it can be operated. Sorry, the sensor either you can use the hydraulic brake or the timer. Yeah, can as well. Advantages and disadvantages of various type of screen. So for the chain-driven screen, yeah, for the Franklin back return. In this picture, it's a Franklin front return. So this is under chain-driven screen, the first one. So for Franklin back return, it's cleaning element, short clean cycle. Disadvantages is the unit has some much moving part that require channel dewatering for maintenance. Yes, for holiday irrigation, disadvantage is less efficient screening movement. Carryover or residual screening to screen wastewater channel. There are some other method here. Not method, it's how it's operated. So for the bar rack design practice, capacity and redundancy, two or more mechanical clean screen are provided so that one unit may be taken out of service without impairing performance. So when you do the best design practice is need to have two uh, bar rack design installed. The location is mainly orchestra screen should be installed ahead of the brake chamber. That is a rule of thumb or common sense. So you remove the big uh, physical item before you do the brake chamber. Then the velocity should at least 0.4 meter per second to minimize the depression of solid in the channel. The velocity through the screen should be less than 0.9 meters at peak flow to minimize passing through the screen. Because the screen is a rack, it's a line, horizontal or vertical uh, line. So for the channel, dual channel must be provided. Typically, they are constructed of concrete. This is how the two channel with bar rack. They must be capable of being isolated by the use of slide gate or recesses. The channel wall for the insertion of started or stop locks. Okay. The velocity of the open channel flow in the channel, this channel is very described by many equations. We have two equations, V and Q. So V1 over N R square R, R2 over 3 S 1 over 2. So V is velocity, N is the coefficient of roughness, R is the hydraulic radius, In this case, cross-sectional area of flow over with the perimeter S is the stop of the gradient line, and A is the cross-sectional area of the flow. So, how can we use this equation to do the design of the barrel? Design the channel for the barrel for Waterloo. Waterloo is example in the book. Approach velocity at average flow rate is 0.4 millimeter per second. Approach velocity at peak hour design capacity is less than 0.9 second. Slope of channel is 0.0001 meter per meter. Width of channel is equal to partial flume inlet. So the partial flume inlet refer to the way this channel design. So by doing a partial flume inlet, you can actually determine the flow rate based on the, let's say, the height of the water outlet. You can read more what the partial flume. So meaning by using partial flume, it doesn't have to uh, install a flow meter, but you can relate it by height of the water. Next is two channel must be provided for redundancy, but one channel must handle the flow for the peak error rate. The fluid watt is 0.6 meter. So in this session today, I show you the solver program in the spreadsheet, which will assist the user to iterate and solve this problem. So the so this is the spreadsheet. It's a simple spreadsheet, but using a solver program. So in order to use a solver program here, this is the solver program. It is not, how to say, it's not a regular. You will not see solver in a normal Excel or default Excel. You need to enable it in option. Go to the add-in. Find the solver is the last one here. Normally, for my case, I already add in. So if you want to use it, then you need to add in into the active protection add-in. So by selecting this Excel add-in, go click this add-in available, click solver add-in, okay. So the solver will appear under the data tab at the end. So for this value, average Q, so N is this is a Manning equation, the coefficient of roughness. The coefficient of roughness, in this case, it's 0.012. Q is 0.4282. S is the slope, width, and depth of the channel. Then calculate the velocity. Okay, we go one by one. Begin with the average design flow rate and set the fixed parameter as follow. This so B5 is here. So n equals to 0.012. B6, this is from previous example. The Q is 0.4282. So P7 is here, 0.01 is a slope, the over meter. So the unit is correct, meter over meter. Because the way they calculate it like this, yeah, it's a slope. Mm, then B8 is the width system. So make a first trial estimate of the depth by using the continuity solution. So A equals to Q over V, A equal to 0.4282 over 0.4, I get 1.07, and then you can calculate that. Get A over W, 0.67. So enter this value in cell B9 as the initial trial value. So B9 is here. Yeah. For the depth of D, because this is a trial and error. So write an equation for the cross-sectional area of flow using the width of the channel and the depth of the flow in the channel that is P8 times D9. C cell B14. C cell B14. So B14 is B9 multiplied by B8. Which is true. Width times depth. We get A. Similarly, another set up the equation for V. V equal to 1 over this is leading equation over NR to the 3 as cell B20. So in cell B20, B20, B20. So this cell is the remaining issue. So you need to write the formula. This in this case 1 over B5. Remember it's 1 over N. So 1 over B5. So N is B5 cell. Then R is C16, C16R. Then S is, where is S? S is C18. Yeah, C18. Okay. With R equal to W times D over W plus 2 times D. So in this case, R is this equation. Yeah. The one set up the equation to compute the area from Q over B in cell B22. B22. Activate the dialog box for solver and designate the target cell B20. There is the one containing the condition of the velocity set equal to mean. So once the code is ready, so you click solver. So the target is C20 B based on the main information. So by changing variable cell, so the cell that will be the manipulated variable is the B9. B9 is the depth. The subject to the constraint is when you just select it. So for the subject to the constraint, you click add. It will ask you select friend in the constraint. In this case, C14 must be equal to C22. C14 must be equal to C22. And C20 here must be more or equal to 0.4. So 0.4 is the minimum with the second here. Equal to min. So if everything ready, you just click solve. Solver found a solution on constraint and activity condition are satisfied. So before you start the question, only there's a the value for v is not there. We do the solver, it will appear. So this is the uh, optimum 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 design. So by changing the cell containing the depth of the flow in the channel B9, that the flowing to constrain the developer. Area with cell with area computed from Q over B computed from with times depth. C14 equal to C22. Remember in the solver, the, the necessity compute in step E of 0.4 or more or equal to 0.4 per second. This is in the constraint in the solver. This one. Okay? This one. Subject to the constraint. So how do we know it's 0.4? It's based on the process. Uh, the manufacturer manually execute the solver to find the depth of basic flow and density of 0.42 meter per second. So repeat the solution process for the peak flow to find the depth 1.4 meter in the second. The channel depth is the depth by maximum flow plus the free mode. The channel dimension are then is 1.6. Expansion plus. The channel dimension is width in meter 6. Depth is plus the free mode 2 meter. A typical bar design ranges. So this that is for the bar design here. So how to use the solver? Uh, it's very interesting. You you change something here, it will calculate the V. Uh, it's easier to do the design. Just put the value and you can see how much is main equation. For the end here, this one is based on a booklet, the book which give an index for the semi-concrete. Typical bar design ranges. So for the parameter, the bar size, mechanical and manual, the width is in 5 to 15 meter. The depth is 25 to 40 millimeter. The clear spacing between bars is between 25 to 50 mm and 60, 5. It's still based on, we can find this information from the CAF and AD. It's there. So for the product design practice, for material, the practice is to use corrosion resistant materials, such as stainless steel and plastic for the barrack. Though much more expensive, the stainless steel system preferred because of their better maintenance history, but it's depend on your food. So normally for plastic, we use it in the lab for the lab session. Student can simulate it. For the stainless steel, for is we use it if the feed is corrosive and at high temperature. There are also fiberglass and concrete actually to design or to build the barrack. The head loss through mechanically clean cost screen is a key design parameter. So based on an assumption of steady two-dimensional flow, the clean water head loss through the basket can be routed using the Bernoulli equation. So for clean and partially clogged basket, the Bernoulli equation gives such as this. So HL is head loss. K, the empirical discharge coefficient. V through is velocity through the basket. And V approach is at approach velocity. G is the gravitational acceleration. So there's this discharge coefficient is taken to be 1.43 for a clean screen and 1.67 for a partially clogged screen. The approach velocity calculated for the channel upstream of the bar reactors into the barrel is on the effective area of the screen openings. It is estimated as the sum of the vertical region of the screen opening. The approximate number of bar is width of channel minus bar spacing over bar width plus bar space. It is the number of bar. Okay, so the number of bar spaces, this is bar spaces, is n bar here plus 1. Head loss through mechanically clean bar rack is typically limited to 150 mm by operation control. The control activate the racking mechanism based on measurement of the different upstream and downstream of the screen. Alternatively, the racking mechanism may be played by a time clock. So either use hydraulic brake or time clock to operate the bar rack. still got time. So there's an example of the head loss. So estimate the head loss for a barrack or what to do with a clean barrack. Shit. Estimate the head loss for a barrack or Waterloo with a clean barrack and with partial look at the script. Is the assumption mechanically clean barrack. Bar width is 15 mm, bar spacing 20 mm, angle from the vertical is 30 degrees. Differential headless rotation of the cleaning rack is 150 mm, and the maximum flow area blockage to shape continuous operation of rack is 50%. So by checking the seat through a bar rack at peak hour flow rate and design capacity, estimate the number of bar and opening. So to calculate the number of bar, we can use this equation. Equation to give any name for it. But using this equation, width of channel minus bars passing over bar width plus bar spacing. In this case, 1600 millimeter minus 20 mm over 50 mm plus 20 mm. So we get 35 bar. The number of spaces is should be plus here. 35 plus 1 is 26. Determine the effective area of the skin cleaned by calculating the total area. I use the depth of flow in the channel at the peak hour flow rate design capacity. So since we have 46 space with 20 mm per space is given in the equation. This is unit conversion times 1.4 is the bar width. Then we have 1.29 meters square from previous example 2021. The peak hour flow rate at TSMC is 4 meters per day. Basically, the bar rate is using V through. Okay, using this equation, get lost. So the V through is 0.93 meter per second, slightly above the recommended uh, velocity. This is velocity when water crossing the rack, the bar. It should not be above 0.9 meter per second. Using equation 25, force velocity of 0.53 meter per second, head loss to the clean bar rate is using equation head loss HL, we get 50 millimeter head loss. So if the bar rate is 50% clogged, the area of flow is reduced by 50%, and velocity to the bar rate is doubled to 1.6 seconds. So the head loss is then 230 millimeter if the bar rate is clogged. And if this head loss is greater than that set initial cleaning, elimination and setting of state is exceeded. Now check the velocity and loss at the average flow rate at design capacity to 57,000 meter cube per day. The depth is 0.64 meter and the cross velocity is 0.42 meter per second. So for the area here, we have 46 space 20 millimeter per space and 0.64 width. So the depth, we have 0.59 meters weight. So the V through in this case is 0.73 meter per second. So this made the recommended velocity through the bar with head loss is around 30 millimeter. All right. Okay. That's all from me. Yeah, finish early. There are many things that we can design. This is one set of it, maybe. Yeah, there's a lot of things. Yeah. So, any question you can just ask me. Try my best to answer. To the check the contact by the number is okay. And so far, we have uh, software as well beside Excel. Okay. Yeah, the easiest way is to use Excel, but we need to key in the code, the formula. We have explained class in our faculty, yeah, which can which can assist the user to get a better understanding the design. Yeah, easiest way still by using the OS Excel for the design purposes. Don't forget to fill up your attendance. It is a compulsory to get to collect the e-certificate. The one is the participation feedback form. The one also important to get the e-certificate. So the e-certificate will be issued by Shadi Copper. So thank you for your participation. Hopefully you learn something here, especially on the design part, uh, especially the Excel server. Not many use server, but in our faculty, yes, the students they they they, they learn about the Excel here, how to use it to do their assignment. For example, assignment, then more than they need to create, develop an Excel uh, spreadsheet that use the solver function to calculate the heat. We have another 15 minutes. If you're wondering, the book that I use is a book beside Macbeth and AD. This book is, let check it. It's a water and wastewater engineering design principle and practice second edition by Mackenzie. A. eh, easier to read and understand. It's a new book. It's published in 2010, to Metcalf in 2003. So if there are questions, then we can conclude the session today. There are many this week. There are many sessions. I give two sessions today. First one is about the Aspen class, in which we do simulation for distillation tower, mesh separator, and a mixer. There are a lot more, and then using Excel, we have vector, we have Aspen dynamic in its process control device, but simulated by Aspen, in which you can set point and see the present value, how it changes based on different method. Yeah, what else you can do using Aspen? The costing as well, energy costing and environmental impact from the process, especially on the emission of gases. Normally, it's what carbon emission. Right. So, all right. So, thank you. So, after attendance, then hopefully to see you again soon.